Hello, physics, mechanics. This question is about train and a worker. A 95-meter long train begins a uniform acceleration from rest. When it passes a railway worker, its front has a speed of 25 meter per second. What is the speed of its last carriage or car? So this is that we have to find the speed of the last car. So this is a train. This is the first car, and this is the last car. And here is the person, and its initial velocity vi is equal to 0, and its acceleration is uniform. And what happens then when this is the last car? So, and after time t, last car, and this is the first car. And what is its final speed? So from here, from this A, and this is B, from A, so Vf is given, which is equal to 25 meter per second. So from this one, we have to find this one. When you find this A, then can substitute in this one. In this case, B, Vi is equal to 25 meter per second, and Vf we have to find. So there are two things. So first thing, so we have to find acceleration. So acceleration, there's no time involved. So Vf, we will use Vf square minus Vi square, which is equal to 2as. Vf is equal to 25. This is 0. This we have to find. This is 95. If we substitute these values, so then Vf square, which is equal to 2 into A into 95, which is equal to 25 whole square. So A is equal to 25 times 25 divided by 2 into 95. To 95, which is equal to 1.73. A is 173 meter per second square. Meter per second square. This is A. Now come to the B. So the B part here, Vi is equal to 25 meter second square second. Vf we have to find, and A is equal to this one, 1.736 meter per second square. So we can find again Vf square minus Vi square, which is equal to 2as. So from here, Vf square is equal to Vi square plus 2as, and Vf is equal to square root of Vi square plus 2as, which is equal to 25 square plus 2 into 1.736 multiplied by 95 whole square root. And this will give you 31.0 meter per second. So this is Vf. So at the start, is first car and the last car. First car have 25 meter per second and the last one 31 meter per second. So there is a difference of 6 meter per second in 95 meters. This is experience seen by the worker. So this is the question. The question states a 95-meter long train begins a uniform acceleration from rest when it passes a railway worker. Its front has a speed of 25 meter per second. What is the speed of its last car? So we have to find this the speed of the last car when the train has 95-meter long length. So it can be done into two parts, first A and B. In A, we have to find acceleration because it's uniform, substituting the value vi is equal to 0 and vf is equal to 25. When you find acceleration, then substitute this acceleration to find the vf again. But in this situation, B situation, vi is 25 and vf we have to find, and then we can find out the value of final velocity of the last car.